Come on. You guys, dude, what? I leave the Discord for a couple hours and it becomes pandemonium, dude. Here we go. Let me see. What's up, Zerudo, dude? Good to see you, man. Ooh, we got a new person. Play Mawats. Play Mawats. Play Mawats.
Oh, yeah, Mechanical said he can let me have one of his bond coins.
Yeah? He wants to give one to you?
Yeah.
Where did he say that?
In Jungle Gym Trading.
Okay, let me check it out. Oh, because you're so close to 30, aren't you?
Yeah.
Have one and return it? Okay, fine.
That man said no, I'm just gonna fake threaten you so you can just actually give me one.
Here, okay. Because he borrowed a bunch from Nick at one point, honestly. There you go. Subtract one from Mechanical. Add one to the user Zaruto. What's up, Mr. Mechanical? Yo, thank you for stepping up and offering to do a Kahoot. And that's really cool. I appreciate that. I appreciate you stepping up to...
Yeah, but it was upsetting when one person had to spam and...
What was upsetting? So yeah, thank you, Mr. Mechanical. I appreciate that. That's a good... Yeah, I'll tell Raiden. That's an okay time for you to spam the students thing. That's fine. People were flooding it with bots. Oh, so we played Minecraft. Okay, whatever. You guys tried. That's okay. You guys definitely tried. Yeah, sorry. My friend was supposed to be coming in earlier, but then her flight got delayed, and so like and I didn't hear from her actually until like she literally like messaged me like 5 minutes before I was right about to do office hours. She's like, "Oh, I'm in LA now." I was like, "Oh shit. I got to drive all the way down to LAX right now." She came 6,000 miles away from Korea. So it was I was like, I can't leave this person stranded at the airport. Let's see. What do we have? We got a couple messages from people. Let's see. What did Megamax say? Okay. Cool. Okay. Face reveal. A face reveal of the girl. Oh, maybe later. Maybe later this week. She's busy unpacking right now. I've been invited to Chef's Den. What's Chef's Den? Jack, do you have a new Discord called Chef's Den? Great. All right. Let me go spam the students again and tell them that we are live this time. Where is it? Where am I gonna do that in? Where's office hours? Students. Yes, Raiden. Alright, Paul. You have to make my Obama Chefy Minecrafters? What do you mean? You want me to give him the role Minecrafters? I'll give him that. Who else? I'm smoking a weed with my manager. What's a weed? Are you smoking weed with your manager? I hope you're old enough to smoke weed. Hello, Megamax. Good to see you, dude. Obama and Chefy. Who's Chefy, dude? Oh, Chef's Den? student I added. Did I see him? Let me see one sec. Oh, did you add him in referral crack? Oh, okay. Oh yeah, okay, cool. Yeah, here, let me give you credit for that. Mr. Mechanical, get you credit for that. And then Sheffy is a Minecrafter, so I'll put him in the Minecrafter group. Yes. For those of you watching, if you play Minecraft, and you like to watch Minecraft stuff, you can get the Minecrafter role, and that'll make sure you get announcements when we do anything Minecraft related. And 500 MT. Yeah, dude, he's just like, just keep giving me the points, dude. I'm thirsty. Like, why is no one gonna make me drink right now? I'm waiting. I'm getting thirsty out here, guys. It's only been 5 minutes. It's only been 5 minutes, dude. All right. Megamex, thank you, Megamex. That's dope. Thank you, Megamex. Thank you. I appreciate the hydration. Cool. Up to 6 viewers. Nice. All right. I'll start off. Welcome everyone to Office Hours. This is a stream where we help you out with whatever math or science homework or even anything in class that's like kind of tough for you and whatnot. I'm here. I'm a professional tutor in Los Angeles, as professional as I can look in all this gold clothing. But I've been a little bit of background. I've been teaching for the last decade, students one-on-one, and this is kind of my way that I want to kind of give back to the community. So I'm doing it by teaching whoever has any questions for free. So take advantage of this, time opportunity to ask, someone who's been teaching math and science to a lot of kids for a lot of time. I can probably figure out a cool way for you to understand stuff that your teacher probably can't. What's up? What's up, Jack, dude?
What's up? Hold on. We are in Warzone.
You're in Warzone. Oh, well, stop playing Warzone. Come hang out. Come hang out, dude.
Hold on. We are in a game.
Okay. Vrinky, my account got hacked. What happened to your account? It's me, Tempest. Yeah, I remember you, Tempest. You got questions. Oh, you can't use your Discord account. Oh no, dude. What happened? Like your Discord got hacked? So okay, this is also why, guys, you should all turn on what I'm gonna call is two-factor authentication. Turn on 2FA to prevent getting hacked. Yes, thank you, guys. Yeah.
Nice.
Ooh, okay. Yo, what's up, dude? Got another follow from Obama.
That's dope.
Thank you, dude. First time chat from viewer Obama. What's up, dude? I already have 2FA. Good, Megamex. Yeah, that's how you don't get hacked. And actually, it's too funny. I just got a new phone. I just got the new Google Pixel 6 Pro, and I need to transfer all my 2FA stuff over because. Here, let me do that actually.
Cool.
There you are, dude. What's up? What's up, Mechanical?
I'm chilling and I'm anxious.
Why are you anxious, dude? What are you anxious about, bro?
When people were flooding the Kahoot.
So who was flooding? Was it random people or people from the Discord?
People from the Discord, because that's the only way you can flood it if you get the code. And
What do you mean they were?
we don't know who it is.
I don't know what flooding
Like,
means.
The way Kahoot is like the way they flood it is like it just spams and like so many people join and it's just bots.
Oh.
It's just annoying.
That's unfortunate, dude.
Because it like crashes the game. I was like, you know what? Let's just play Minecraft.
Yeah, at least they can't hack that, right?
And then my grams came and then kind of just stopped there.
Here, 1 second. Let me do.
A great bummer.
Export accounts. Yes, next. 1 sec. This is my 2FA. There you go. Now I got my 2FA. Okay, good. Cool. All right.
Let me go back on Twitch.
You're good. Did you want to go over one of your questions, Mechanical, dude? You want to go over?
Yes.
Here, let me stream so you can interact with it here. Because you get a bond coin for answering some questions, dude. Bots joins like lots of them. It's okay, guys. I appreciate you guys taking the initiative and doing something while I wasn't able to stream. But I'm here now. And Brinksy has a question.
Yes.
Cool. All All right. If you have a question, Darth Gold will come out tomorrow. Ooh. If you have a question, post it in the Discord. Can you post it in the office hours? Mechanical.
I
What's
can't post it because I didn't go to school yesterday.
oh? Well, you can. Well, I think you posted it last time, right? It was like how do I find the 100th term? Is that what you were asking?
Yeah.
Do you still need to do that one?
Yeah.
Okay. Well, then here, let's just do that one. Where the fuck did you post it though? Oh, it's not in referral credits. Sorry, I'm in the wrong fucking thread, dude. Yes,
Just
Patty Graps
office
has stuff.
hours.
Okay, thank you, Patty Graps. Sorry, I was in the wrong chat the entire time. Here, let me do mechanicals real quick because I meant to do his at the end of office hours yesterday and I got held up. So here, let's do this real quick. Mechanical. Can you see this, dude?
Let me go to the thing real quick.
Yeah, you good. You're
Yeah,
good.
that's what I have, right? But like the way I was doing mine's like with like different, like she gave that as an example.
Uh-huh.
She would like use different numbers and create one and find it to the 100th term.
Okay, good. Okay, nice. Here's an example. So what we always need to remember, right, is that there's always like an equation for like how to find the nth term. You've done it for arithmetic sequences. What was it for arithmetic sequences, right? It's a sub n is equal to what?
A1
Good.
plus b multiplied by n minus 1.
Good, dude. Yes. Well, it's a1 plus d times multiplied times n minus 1. Yeah, right that. Good. Okay, good. This is
Yeah.
arithmetic. All right, cool.
Then geometric is, it can actually go in two different ways, but
It
I do
can.
it the way the teacher told me. It was an equals a1 plus r,
Oh, plus r.
and then it's n minus 1
N minus
multiplied by n minus 1, or I mean,
No. I think it's
I
a1
would
times
do
r
that.
to the n minus 1. I think this is what it is.
nah, it's plus. It's not times.
Are you sure, dude?
Mhm.
Well, look at this right here.
No, it's plus. I don't know why it's like that, but she said it was plus.
It's not plus. I'll tell you straight up, it's not plus, and that's just from my years of experience in teaching this. It's
That
definitely not
teacher-
plus.
that could lie to
Your
me.
teacher, did my teacher lie to me?
That's dope.
That's not really dope, but yes, your teacher probably did lie to you. It's okay. This is the formula for geometric sequences. Okay. What's up, Jack, dude? Okay.
What's up? Why don't we get today?
What is he saying, dude? Okay. All right, so let's say we have a geometric sequence here, mechanical dude. All right, let's say I have let's say that a to the 3 is equal to I don't know, let's say 40, okay? And a to the 5 is equal to, I need another one. One thing. 8, 16, 32. Is equal to 250,
Oh, now I know-
256.
Now I know the.
No, you don't know the numbers yet. You don't know them yet. You don't know yet. You don't know yet. You don't know. 8, 16, 32, 5. 160, okay? And I'm going to ask you, for instance, what is a to the 100, okay? So let's see how to do this, right? So how do you think you would do this one? How do you think we'd start this one?
Give me one
Start
second.
hydrating,
Let me
boy,
keep those
dude. Thank you.
laughers up,
You guys
'cause
are all
just-
making me
you just-
hydrate, dude.
You were just counting, like you were just whisperly counting.
I know I was whispering. I should have muted my mic, but
Mm.
that doesn't help you though. You don't know what a to the 100 is just from like yeah, I'm
I
drowning
know
rating,
A to
dude.
the 100 isn't, but kind of find out what the ratio is. But okay.
Yeah, let's try and do it. So again, I could figure out a to the 100, right, mechanical dude? All I need to know is what A1 is, right? I need to know what R is, and I already know what N is, right? Because what is N if I'm looking for the 100th term?
100.
Good. Nice. So you see how I only need this and this, right? Two things I don't know. I don't know A1, and I don't know R. Sometimes they'll give you A1. In this case, they didn't. They did not give you A1, right? So we got to figure out what A1 is.
Mm-hmm.
Do you know how to do this, or
So-
do you want me to like show you the trick? There's a trick to it.
Show me, because I couldn't do it this morning.
That's
because I
okay.
didn't go to school today.
Okay, so what we're going to do, we did this similar with the arithmetic sequences. I want you to write out what A3 would be in terms of this, okay? So A3 would be equal to what?
A1.
A1 times
Multiplied by r
times r, right? To the what?
to the 99th power.
No. At
Oh,
A3
yeah,
though.
Doctor, go
What's
back
No, to the
A3?
here
second
too.
power. To the second power. My bad.
Second power. 3 minus 1. What's up, Zerudo, dude?
Let's head at bot tier 2.
Awesome, dude. I will get that to you after office hours. Don't worry. But congratulations, dude. Congratulations on I know you've been waiting for a while for that one. So, congrats, dude. All right. All right, let's write out A5 then. Oh, and also, we know A3, right? A3 is equal to what? What is A3 actually equal to? Mechanical. What is A3 equal to?
It's 40.
40. Good. Okay. So now let's write it out for A5,
My
okay?
mic was muted.
You're good. Now I'm going to use the A5 one. So what I'm going to write for A5?
A5 equals A1
Good.
times r to the 4th power.
4th power. Good. And that's equal to what?
160.
160. Okay, cool. This is, again, guys, this is what we call an algebraic system of equations. So I have two equations here. I have A1 r squared equals 40, and I have A1 r to the 4th is equal to 160. Okay? How many things do I not know? How many variables do I not know here?
The ratio in the first term.
Good.
Term.
Good. You don't know r, you don't know A1. Now, we know in algebra, right? If I have two unknowns, how many equations do I need?
2.
Good.
Right?
Yes. Two unknowns means I need two equations. You see how I have two equations? This is an equation, and this is an equation, right? I have two equations. All right?
Yeah.
So what's one way that we could be able to figure out what one of the things is, you know? I think we used, it was called substitution last time, is what I did. I called it substitution.
Yeah, we substituted the
So how do you do substitution?
I don't remember.
So okay, doing substitution here. I'll give you a little trick. Let's say I have like x plus y is equal to 6, and x minus y is equal to, I don't know, like 2. Okay. Another cute way they do this, they say like, if the sum of two numbers is 6 and the difference of the numbers is 2, what are the two numbers? Like, what two numbers add to 6 but subtract to 2? This is how they usually write this out. What substitution means is I want to turn one of these equations into just like x equals blank blank blank, or just like y equals blank blank blank. I want to get one of the variables in terms of the other one. Okay. So what could I do to write this as one variable in terms of the other?
I don't know, but I know what the x and y are, but I don't know how to like
Yeah. Okay.
put
Well,
it in that way.
so let's write out, for instance, let's say if I want to write this as x equals something, what would x equal? Like, what would I have to do to make it be x equals? Nice, Megamax. Good job on the bond coin.
Vision.
No, you're gonna minus y on both sides. You see that? See how-
Oh yeah.
right? So this becomes x equals 6 minus y, okay? Do you see how now you have an equation, right? That you can take this x, and now you can plug it back in, all right? Into the second equation. So now what am I going to end up having once I plug in 6 minus y for x down here? What do I get?
6 minus y equals 2.
Well, it's 6 minus y minus y. Don't forget there's still another minus y, right? So this
Then
is
it becomes 6 minus 2y. Then?
good. 6 minus 2y equals 2. All right, solve for y.
You subtract 6 on both sides.
Good.
Right?
Yeah, you can do
Or
that.
do
That's fine. That's
then it
fine.
becomes
Negative 2y equals
-4.
negative 4. Okay, what does y equal?
Positive.
Positive
2.
what? 2. Good. Y equals positive 2. Do you see how you solve for one of the variables? You got it?
Yeah.
That's substitution. And then once you know one of them is 2, right? If I know this bitch is 2, like, what is x?
4.
4. Good. That's how you solve a substitution, okay? You take one of the equations and you get one of the variables by itself equals something. And then you plug that in to where it is in the other equation, and then you solve. Because what that does is that gets rid of x, so that now we have an equation that's only based on one variable. It's only based on y. You see how there's no x's here? Kicked all the x's out. We're like, fuck our ex-girlfriends. Like, I don't need more x's, you know?
Took that quick screenshot, you know.
Yeah.
Okay, so then with this now we just have to substitute this one.
We
So
need to
then
substitute this one.
it
So we
so then basically let's just change the variables. So
okay.
then it becomes like then it becomes like x1 times y to the second power, right?
Or you can just say x times y to the second power is equal to. How do I get in there? So Brinksy, are you in the Discord, Brinksy? I think you are, bro.
He was just in the office hours voice chat.
And then join the voice chat.
Mr. Gold.
Dr. Gold, it's not Mr. Gold. I didn't spend 9 years on a PhD program to be called Mr. Gold.
Too bad you're now known as Mr. Gold.
Oh no. All right, x y squared equals to 40. Yes, cool. And we could rewrite this one as x y to the fourth is equal to 160. That's okay. You can do that if you want. Okay.
Mhm.
All right, how am I going to solve this though?
Now we have to find what x is, right? So then,
Mm-hmm.
or y, we have to find one of the variables first.
Yeah.
Um.
I would do what x is equal to. Because
So we'll
do
find
you see how this
x
is like a
and then
y
we do-
squared? So having to get y equals is going to be kind of tough.
All right, so let's find x first then.
Uh-huh.
We do division, right?
Good.
We do doesn't it become like x equals 40 divided by y to the second
Good.
power?
40 over y squared. Very good. Very good. Very good.
Yeah.
Okay.
Then,
Now what do I
then
do?
we substitute it.
Good. Substitute this into here, right?
Yep.
So now I have 40 times y to the fourth over y squared is equal to 160.
Mm-hmm.
Okay. Do you see how now this
So
is only in
then we
terms of
get-
one variable? It's only in terms of y, right? We can solve this.
Yeah. So then
Yes, Grim. Great responsibility, dude.
doesn't it become like y just y or like
No.
y2, right?
Y2,
Because there's
y2.
four
Yeah, okay. Remember, if something is like y to the a over y to the b, that's equal to y to the a minus b. You always do this one subtracted from this one.
Oh, okay. Yeah.
So
it
this is
becomes
4 minus 2. So this just becomes 40 y squared equals
Y2.
160. Good.
Yeah. So then, do we subtract 40 from both sides?
No, because the 40 is multiplying it, right? 40 is multiplying it.
Mm-hmm. Yeah.
We always do the
we-
opposite of what's happening. So if
we
I'm multiplying, what's the
subtract
opposite?
160.
Nah,
Oh, we
no.
divide. We divide. We divide.
Divide by 40, right? Divide by 40.
Yeah.
See how you get y squared is now equal to 4?
Yep.
Cool. But I don't want y
Wait,
squared.
4,
What do I
8,
want?
12, 16. Yeah.
Okay, Obama. Go eat something nice. I just had In-N-Out. That's pretty dope. Oh, yeah, stay and watch it, dude. Yeah, rack up those channel points. The more channel points, Obama, that you rack up, the more bond coins you get. So just watch the stream. You're good.
Or you can get the legendary.
Oh, dude, thank you,
gold
Megamex,
dog.
dude. Thank you, Megamex. That's very nice of you to say that. Megamex, the 2-year anniversary subscriber, dude. That's sick. You got that 2 next to you.
You mean 2-month anniversary?
Or 2 months, sorry. I'm sorry. Yeah, 2 months. Sorry. There was a lot of traffic on the 405. My head is like, ugh. Okay, so what's y? What's y? Y squared is 4. What is y going to be then?
Don't we basically make it like 4 squared, right?
No. So to get rid of things that are squared, what do?
I don't remember.
You square root. Square root.
Oh yeah, you square root it.
Good. You square root both sides, right? So this becomes, because the
Yeah.
square root of a square is just rego, so this is y. And then what's the square root of 4?
2.
2. Nice. Y equals 2.
So
Okay.
now y is 2, right?
Yeah. So what was
So then
y?
It becomes
Y was what?
y was the ratio.
Good. That was the ratio, right? So now, can I use this in order to figure out what A1 is?
Yes. Yes.
Or
Well,
it's in my
not
mom's.
quite,
I appreciate that,
not
Megamex.
quite, but
I don't
not
think your
quite,
mom's prime is ever
because,
gonna run out.
This is just a ratio,
Good.
unless we go back, like
Yeah.
divide instead of multiplying, like
No.
like, for example.
No, don't overcomplicate things, right? So we have y, right? We got y. We're just trying to figure out now what x is.
Yeah.
So if I know what y is, right? Do you see how I could
So
just
we're gonna
plug this?
plug it in then.
Either
It
one.
can become like,
You can plug it into this one or into this one. Doesn't matter.
yeah, it can become like, it can be like 2x to the second power, right?
No. Okay. So this is gonna become okay. Let's plug in y is equal to 2. Let's plug it into this one. I think that's what you're doing, right?
Mm-hmm.
Okay. So if I take this and I plug it into this one, right? I'm gonna get x times y squared, right? Y is equal to 2, so this is 2 squared equals 40, right? So now I get that x times 4 is equal to 40. What is x equal to?
X is equal to 10.
Good. X is equal to 10. Good. All right, awesome. Okay. So you see now you have
So
x,
now that we know that.
and that was
X,
what? Which
yeah,
one was that?
the first term.
That was a1, right?
Mm-hmm.
So now, if I ask you to figure out what's the 100th term, let's go back to like what the original question. What was the OG question, man? Like, it's like, yo, what was the OG question? Was like, what is a to the 100? Do you see how now you can figure this out, right?
Yeah, it's gonna be like 10
Good,
multiplied by 2
Good.
to the 99th power.
perfect. Which I don't
And then it
can
becomes-
let's see if a calculator can do that. I don't know if
2 times 99 is 100.
No, it's not. No, it's not 2 times 99. It's 2 to the 99th.
Oh, 2 to the 99th power.
Yeah,
Yeah,
which is
you're-
fucking
yeah,
huge,
that's
dude. It's 2
crazy.
times 2 times 2 times 2. Yo, bird, yo, yeah, nice. Good job on the bond coin. So this is actually this is 2 to the 9th, which is a massive number, and then timesing by 10. This ends up being 6.34 times 10 to the 30th. This is huge. It's a huge number.
6 times 3,
Yeah.
3, 8, 2, 5, 3.
Yo,
0,
Grim,
1,
thanks for the
1,
sub, dude.
3, 3, 0. Boom.
Dude, we get another sub, dude. We got
Numbers.
another sub, bro. Wow, dude, they resub. Thank you, Grim, dude. I appreciate that, dude. Wow, look at that. We got 2 subs in 2 days, dude. That's sick. All right, does that make sense? Does that make sense to you? Sorry, mechanical.
Yeah, that actually sums it up. Yeah.
Good, man. All right, I'm glad that makes sense to you.
100 term by substituting.
Uh-huh.
Let me take a screenshot of this real quick.
Here,
Can
I'll
you
just
go
I'll
back down,
download it.
please?
Here, let me just download it for you. I'll just download it for you.
All right, thank you.
Here, I'll download this as a
Fast.
is it? Well, actually, you probably use fuck the let's do a PNG. I think a PNG is probably better.
Your mic
So it becomes
is
x
lagging
to
out.
the second
My
power.
mic is lagging out.
equals-
Is my mic lagging out?
It's lagging.
Is it?
No.
Yeah, I don't think it is. I've
Yeah,
been.
it's
He's like, your mic is lagging,
it's
dog.
lagging. He sounds like a robot.
Oh, that's your internet connection then, dude. They're mechanical.
Why is the second
Mechanical.
power
I tagged you and I
equal
sent it to you so you can see it. It's a big JPEG there if you want. Thank you, Megamix.
Third. All right, thank you.
Hey, yo.
Yeah.
All right, Patty, you here? You're next up. You posted a
Yeah,
question. What's
I'm
up?
here.
All right, Patty, cool. Thanks for chilling while we go over this.
Next.
And then Brinksy, I'll answer your question next, Brinksy. If you can take a screenshot of what you need help with and post it in the office hours chat. Here, let me tag you real quick. That'll help me go through it. If you don't have a screenshot, it's cool. You can just ask me on the stream, but you know, if you look for something to do in the meantime. Here, let's go through this, Patty. All right. Ooh. Okay. This is transformations of functions, right?
What's it called? We did a quiz on our last like graphing unit, and
Uh-huh.
for some reason our teacher was just like, watch these 3 videos and take notes.
Oh, that's great. Love that.
I hate those kind of notes.
Yeah, well, so just take notes.
And
But then you're like, well, I don't know
I-
what the fuck's important.
I mean, the woman that was like commentating the video and like taking the notes and stuff, she's a teacher at our school, but like she highlights the stuff, but like I just don't really understand it, to be honest. So I feel like I need someone else to explain.
That's fine. That's why I'm here. Okay. Okay, so whenever we have transformations of functions, what we have is called like a parent function, which is like
Yeah.
what the function would look like if it wasn't modified, okay?
Mhm.
So if we're looking at this, for instance, okay, what is the parent function of negative square root of x minus 4? What's the parent function of that?
Square root of x.
Good. Yes. So y equals square root of x is really, this is the parent function, okay? Which looks something like, something like this, basically. Okay.
Yeah.
All right. What we do when we look at transformations is we look at what's happening closest to the x, and then we move outwards. Okay. So let me show a couple examples of what could happen. So let's say we had square root of x, and then it was +3, but this +3 was still under the square root. Okay. So close to it. Do you know what that +3 would do?
Would the +3 move it to the left?
Good.
3?
Would move it to the left 3. Good, yes. Anything inside the hut, or like very close to the x. The other example is like they usually have like x squared, right? And they'll do like x minus 1 squared. You see how this is like inside the squaring or whatever's happening?
Yeah.
Yeah. Anything that's very close to the x, like inside and whatnot, that's always going to deal with horizontal shit. And anything outside of that is going to deal with vertical stuff. Okay?
Okay.
That's kind of the trick is that. So this stuff. So let me this is like in general what this could look. This could look like a to the square root of x minus h plus k, and okay, they could also put a multiplier on x. So they could also do this if they wanted to. This is all the transformations you could do to it. Like if you really just wanted to like mess it up. So this stuff would all be horizontal.
Yeah, and then everything else outside is vertical.
Very good, Patty. Yeah, nice. Yeah, it's all a pattern, dude. Honestly, and I hate that they don't teach it. That like it's a pattern. I'm like, it is a pattern, dude. Like, okay, cool. All right. So right, you're right. This would move it to the left. And yeah, the other thing is the horizontal stuff is all backwards, right? Like adding goes to the left. You're just like what?
Yeah.
Also, multiplying by things. Usually, you multiply it by a big number, it stretches. But in the case of horizontal stuff, if you multiply by small numbers, it stretches, which is weird. But we'll show that. Okay, so this would be left 3. Okay, so what if I had, for instance, square root of x minus 3? What would this be? But notice how the minus 3 is outside of the square root of x.
Yeah, would it go just down 3 on the y-axis?
Yes, good. Down 3. Good. Perfect. All right, awesome. Okay. So you understand the up, down, left, right. Great. Okay, so now let's do the harder things, which are the reflections. Well, okay. Which are the stretches and the reflections, okay? So let's say, for instance, I have the square root of 2x, okay? Do you know what this 2 is going to do to it?
Not sure.
Okay. So anytime you have a number multiplying by it, that's going to be some sort of stretch or compression, right? So instead of just shifting it, it's going to like literally like stretch it or compress it. For horizontal stuff, this is going to be a horizontal compression. By 2, okay? So what that means, Patty, is that this thing right here is going to like get like compressed like this way. So instead of it looking like the purple thing, it would look something like, I don't know, like this thing. You're like going, you're just compressing it in. The easier way that this actually gets visualized is a lot of times if you, for instance, you had, let's say you had like this x squared, a horizontal compression would then look like this. You see how like it gets thinner around like the...
So it comes closer to the y?
Good. Yes.
Axis.
Yes. Oh, that's a good way. I like that. Yeah. Closer to the y-axis. I like that. That's a good idea. Yeah. Closer to the y-axis. Good. Okay. If this was y is equal to the square root of 1/2 x, this would be a horizontal stretch by 2.
So if it's a decimal,
Good.
then it's stretching.
If it's between 0 and 1, it's stretching it, and it's stretching it by like 1 over that, right? So yeah, this again, the horizontal stuff is always messed up, but like the vertical stuff will make more sense to you. Let's say, for instance, I had 3 times the square root of x, and I just have this outside, right? This is a vertical stretch by 3.
Yeah.
So remember, this was further away. So horizontal stretch, right, is making it like fatter, right? So this is further away from like, further from y. Vertical stretch by 3 is now further from x. It's like you took your function and you stretched it up from the x-axis, right?
But it would still come from the origin, right?
Good. Yes. Well, actually, so we'll have to go over that. Because there's an ordering to it. Yes. If it's written just like this, correct. It will just stretch it just from the origin. I'll show you like when this can kind of go wrong. Okay. And in this case, if this is a decimal or a fraction, this is going to be a vertical compression by 3. By 3. So this is closer to the x-axis. Cool. Oh, nice, Brinksy. Yes, good. Thank you for posting something, dude. Okay, good. All right. Okay. The last thing I got to teach you are reflections. Okay. Yo, Nick. Good to see you, Nick. Okay. Okay. So now we could have, let's say we have the square root of minus x. Okay. Versus y is equal to minus square root of x. Okay. These are two different things. Okay. What do you think this does? What do we know about stuff that's inside the square root or very close to the x?
It affects horizontally.
Good. This is
The square root can't be negative.
It can't be, but yeah, in this case, well, okay, because what could happen is I could also put like some like plus 6 shit over here, right? So for instance, I could move it to the left and then flip it. But okay.
Gotcha.
This is a horizontal reflection. Okay. Over the y-axis. So this is the case of like, say we have something like this. This flips it over here. See how we flipped it like as a mirror?
Yep.
Uh-huh. This is then a vertical reflection over the x-axis. Okay. If I could spell x-axis today. So instead of this, for instance, it would become this. See how it reflects?
With the what's it called? Like if with one of my examples, it was something like the one you just showed, and then I think it had, what was it, like
It was
plus
this.
something?
With this one right here?
-4.
Yes. So here.
So that would bring it down on the y-axis, right?
So
it would just go -4.
here's the tricky thing. So when we have multiple transformations happening on something, Patty, you need to do them in the order that they hit the x, okay? So because it matters whether you move something and then reflect it or whether you reflect it and then you move it. Does that make sense?
Yeah.
Like, if I have this, I reflect it and then I move it, that's going to look different than I move it and then I reflect it. Right?
Yeah.
So you always want to do the stuff closest to the x. So looking at this, there are two transformations happening here, right? There's this minus on the outside, right? And what is this called? This would be what type of? This would be a what?
Vertical reflection.
Good, vertical reflection. Very good. What is this -4 going to be?
That's vertical transformation.
Good, yes. Yeah, this is just down 4. Just call it down 4. Okay.
Okay.
So if I look at the original equation, right, which is just the square root of x, okay, I have two transformations I need to do. Which one do you think you're going to do first?
One's closer to x.
Yeah, which one's closer to x?
Reflection.
Good. Yes. So the first thing you're going to do is the reflection, okay? So you're going to reflect it over this axis, right? So that's going to look like this because that's a vertical reflection, okay?
Yeah.
And then what are you going to do next? What's the next transformation?
The down 4.
Good, the down 4. Very good, very good, very good. So good. This was the vertical reflection, and then we're going to do the down 4, okay? So now I'm going to move it down 4. 1, 2, 3, 4, right? So now it's going to look something like that. Does that make sense?
I just just in terms of like what's closer to x, I feel like is gonna mess me up a lot.
Okay. Well, here, the best way to not mess you up is just look at a bunch of examples, right? Here. What's happening here? What are the two transformations?
Horizontal reflection.
Good. Horizontal reflection.
And left 3.
Good. Left 3. Which one am I going to do first?
The reflection.
Good. Yeah, do you see how that's closer? I mean, this is definitely closer than this, right? This is directly multiplying it, right? But this is like adding it, like kind of. And it's kind of subjective that it's like. I think it's pretty clear that this one's closer than this one.
Yeah, because the negative has something to do with the x.
Good.
First.
Exactly. And even so, this has something to do more than, for instance, something multiplying outside the square root, right? Or something adding outside of the square root. So like
So
in terms of
that's like
in terms of priority, right? Closest means like, is it within the square root? Is it within the square? And then even closer is like, is it multiplying? Multiplying is the closest you can get to something. It's probably like a life story or something there, but yeah. So the original function, right, looks like this, and then we do the horizontal reflection, right?
So it's just across the y-axis.
Good, like this, good. And then what do I do next?
You move along the x-axis to the left.
Left 3. Yeah, Nick, did you catch that, Nick? Did Nick catch it? Dude, I think Nick caught my joke. Nick, you always catch my jokes. Yes. Okay, good. All right, here, I'm going to give you a couple of other ones, and you can just tell me what the transformations are and like what happens. So let's say we have y is equal to negative 1/3 square root of 2x minus 4 plus 6.
Holy shit.
I know. It's like, let's make it really legendary hard.
Legendary hard and literally include every single thing we just
Exactly. Well, this is all about the like, let's put it all together. You know, like you know, I teach you little bits and whatnot, and at the end, this is the boss battle. This is the boss battle you got to do. Like, hopefully you've beaten enough of like the mini bosses that you're like, oh, dude, I got the boss. I know how to do this.
All right. So we'll start off with what's closest to x.
Good.
So it's the 2,
Good.
right? So that stretches it. No, it shrinks it.
Good. Shrinks it because it's right. It's in the horizontal domain, right?
Yeah, shrinks the x or the function, and then.
So horizontal
subtract
compression
4.
by 2. Good.
Yeah, horizontal compression, and then the minus 4. That's right 4. Right?
Nice, dude.
And then I guess we'll start with the 1/3.
Good.
Negative 1/3. What's the 1/3 thing? I know we did something.
So this was, remember, everything inside deals with horizontal. Everything outside deals with.
Everything else is vertical.
Good.
So, wait. So the 1/3. Would it be? It's the thing with closer and further away from the y-axis.
Right, which is compression and stretching. Right. Yeah.
Okay. Yeah, but it's negative. So.
Ooh. Yeah. So there's 2 parts to this, right? You can also think of this negative. Think of this as just like a -1 times this. Think of it as like there's technically 2 things happening at once here, right? There's some sort of compression or stretch, and there's also what does negative do? There's a reflection, right? Negative does some sort of flip.
Okay. So it's a y reflection.
Good. So first you can say is a y reflection. You can say in this case you can say either. Like you can say either. You can say reflect it, then stretch, or you can say stretch and
so
reflect.
y reflection, and then. Is the 1/3 stretching?
No, so that's a compression because it's less than 1 and it's on the outside.
Be right back.
Okay, Jack, good to see you.
Okay, so what's it called? With the horizontal compression, right?
Yeah.
It's the other way around.
Good.
But with the y compression or
the vertical compression.
Vertical, yeah, it's different. So it's expansion or whatever.
This is a compression because it's less than 1. Yeah.
Yeah.
Oh, dude, thanks, Obama. I appreciate it, bro.
And the negative is the y reflection.
Y reflection. You can do these in either order. It doesn't matter actually. But yeah. Okay, and then what's the final
thing? And
thing?
then the +6 is moving it up 6 units.
Good. Yeah. Move it up 6. Cool. That's it, dude. That's all you have to do.
Yeah, and then I have to graph the stuff.
Yeah, well, you know, the hardest thing, right, is determining what to do and what the order to do it in. After that,
Mhm.
it's kind of just, you can graph it. It depends what the teacher asks. Sometimes they'll ask you to list out what the transformations are. Sometimes they'll ask you to graph it. Um, if you really have to graph this, honestly, I would just pick points, because trying to figure out exactly how much it stretches or it compresses by eye is very difficult. But if you just pick X and Y points and plug stuff in, you can graph it easy enough that way. But this is good because what the teacher will usually ask you to check if you actually understand what's going on is they'll ask you what are the transformations. And so 9 times out of 10, this is what they want. They want you to list out what happens.
Okay.
Yeah. Does that make more sense?
What is this? Yeah, but what is this helpful with in the future for you?
Okay. What is this helpful for in the future? Why do I actually need to learn this shit?
Yes, literally.
Let me think. I mean, it's helpful besides the obvious answer that you don't want to hear, which is it's helpful for later math classes,
Well, yeah,
Like,
but what is it What math class would I have to look out for that involves this?
even anything like calculus, physics, because okay, what these equations can look like, for instance, is let's say we're describing the motion of throwing a ball. Have you done physics yet?
Junior year.
Okay, cool. So, you haven't done this yet, but I can show you real quick what it is. So, if you have, for instance, a ball that you're throwing, and a ball takes a trajectory that looks something like this, right? Where this is y versus t. This is actually a parabola. Do you know a parabola?
See that?
Right? When you throw a ball, the path that it takes is a parabola. And that comes down to the equation where y is equal to y naught plus v naught t plus 1/2 at squared. So in simple forms, this really looks like at squared plus bt plus c. You see how this is a quadratic? Quadratic equations are always something squared, something times something, and then something without times something. And then you guys probably learned do you learn completing the square and shit?
Completing the square.
Making this into factoring this. How to factor a quadratic.
I feel like I definitely did learn, but I don't remember.
It's okay. When you get to it, again, come ask me. I'll show you how you do it. And you won't forget it. You can turn this into something that looks something like this. X minus h squared plus k is what you can do. You can it's called completing the square. And in doing that, this y equals x minus h squared plus k looks very much like the parent function y equals x squared, right? But and it's actually going to be negative. Yeah, but do you see how there's some transformations on it, right? There's a minus h here. What would this minus h do, since it's very close to the x?
Minus h, that would go right.
Good. So
however many.
Good. This would move it to the right, right? So if you had an original just parabola, this would be y equals x squared, right? You would end up moving it to the right by h, right? And then what would this do?
That's a vertical reflection.
Good. Vertical reflection, right? So the vertical reflection would then flip this, okay? So you see how now that would become something like this?
Yep.
And then what would this plus k do?
That's up and down.
Up and down. So you see how this now moves up here, and now you get your path?
Yeah.
So this is a cool way that, for instance, if you see the equation for your trajectory like this, and then you can write it like this, and you can understand the transformations, you know that the vertex, which the vertex is this point, right? Which here is the lowest point.
Oh.
But here, this would be the highest point.
Yeah.
You can figure out, for instance, the vertex. This would be h comma k. Whatever h is and what k is, that's what it turns out. What it ends up being is this highest point is now h comma k, because it used to be 0, 0, right, for the original function. You moved it over to the right h, and you moved it up k. That's what the highest point of a ball is that you throw or something.
Sure.
Yeah. So that's why it's useful. That's why it's cool to know that. Cool.
Yeah.
Nice. Okay, good job, Hattie. Let's get you some points for that. And then Brinksy, you around? I'm gonna teach you. You're my last student today, dude. Let's go through it.
All right, now I gotta go study for some Spanish.
All right, dude.
So-
Stay. Estudiar mucho para tu examen.
Gracias.
Gracias. All right, Brinksy, dude. What's up, bro? Yeah.
Hello?
Yeah, Brinksy, how's it going, man, dude?
Good.
So it looks like you're doing like order of operations, right? This kind of looks like some order of operations stuff, yeah.
Yeah.
Okay. Do you know a cool little mnemonic for order of operations?
No.
Did they ever teach you PEMDAS? PEMDAS?
Well, yeah, they did, but I didn't really pay attention.
Oh, okay. Well, you can pay attention this time.
Yeah.
Okay, here. It's okay. PEMDAS. Oh wait, no, I fucked this up. It's okay. I sometimes mess up. I'm human. Okay, this is what I want. I want my colors to be correct.
Gold. Hey, Gold.
What's up, Jack?
Don't play Fortnite after that or what?
I gotta go work. It's kind of late for me right now, but I'm sorry. My friend's flight got in late, but I will try to play with you tomorrow. Is that cool? That cool, Jack?
Yeah, what time will you be alive tomorrow?
Hit exclamation point schedule in the chat. It'll show you, dude.
It doesn't show it.
Oh, okay. If you do exclamation point schedule, really? You can do it. Do exclamation point schedule. It'll tell you when I come on. All right. Brinksy, PEMDAS. You don't know what PEMDAS stands for, but I'll tell you. P starts for parentheses. Do you know what E starts for? You got to guess?
Exponents?
Yes, dude. Nice, bro. Exponents. Exponents. Good. What do you think M starts for?
More multiplication.
Oh, wow.
I guess.
Dude, I think you did pay attention, honestly, dude. D is what?
Division?
Division. Very good. And then A is?
Adding.
Good. S is?
Subtracting.
Very good. Very good. Okay. This is they call this the order of operations because this is the order that you're supposed to do things in an equation, okay? If we look at here, right? We got a couple things going on, right? We got some adding going on, and we got some multiplying going on, right? And so we want to know which one do we need to do first, okay? So, looking at the order of operations one, which one starts first? What's the first thing we got to do?
Multiply?
Good. So I'm going to multiply these, and here's the key thing. You see how I group these by color, right? Actually, I screwed this up again. I got to change this. Okay, if two things are the same color, then technically you do whichever one is closest to the left first, okay? And I'll show an example of that, okay? Okay, good. So this is 1 times we're going to do the 1 times minus 4 first. What is that?
That's -4 still, right?
Good, -4. And then we got to do plus -2. What's -4 plus -2?
Isn't that, isn't -6?
Good.
Or-
Nice, dude. -6 brings C. Good, dude. All right, here I'm gonna give you something tougher, okay? Because these are kind of easy, but always like here. Let's leave this over here. Okay. Let's say we have 3 plus x times. Do you guys use dots for multiplying yet, or are you still using x's?
We use both.
Okay, you should use dots. I hate that they taught me first with x's, and then you're like, oh wait, but x's are variables. So it's kind of annoying. All right, let's say we have 3 plus let's say 4 squared times 5 minus 3 times 2. Okay, here's a good one. Here, actually let's do this a little harder. Let's say 4 divided by 2. Okay.
Mm-hmm.
All right. Which thing are we
Yeah.
gonna do first here?
Parentheses.
Good. Parentheses. So when I see parentheses, right, I'm gonna look straight at here, and now I'm just gonna look at this, and now I gotta restart PEMDAS and see. Okay, within the parentheses, which thing am I gonna do first?
Your exponents.
Good. Very good. Very good. Okay. So I'm gonna do the exponent first, right, which is this. So what is that exponent gonna become?
It's going to become 16. 16?
Nice.
Yeah, 16, dude. Okay. So now do you see you have 3 plus 16 times 5
Mhm.
minus 4 divided by 2, right? That's what we have so far. What do we do next?
We add 16 to 3.
Good. Yes, we do, because this is still within the parentheses. See, we're still doing the stuff within the parentheses first. Good. So that's now going to be 19,
Yeah.
right? Times 5 minus 4 divided by 2. Okay. Now what do we do?
Mm-hmm. Now we multiply by 5.
Yes, good. 19 by 5. Do you know what this is? Do you know what 19 times 5 is?
19 times 5. It's
What's 20 times
You
5?
got it. I believe in you.
Come on, man, you got this.
Just do the 20 times 5 minus 5. Boom.
Yeah, that's a good one.
oh
And
95.
retrack your steps and do
95.
it carefully.
Nice.
Yes, dude. Good. This is 95. Good. All right. What else am I doing over here? What else am I doing?
It always helps to just count your steps and do them slowly.
Yeah.
What else am I doing,
Seven
Brinksy?
guys, I remember this.
Get confused.
What do I do next? So we did the 19 times 5, and
Yeah.
what's next?
Do we divide?
Good. What do we divide?
95 by 2.
Ooh. Not yet. Not yet. Yeah, not 95 by 2. Because see how we have 95 minus 4 divided by 2?
Yeah.
We're going to do the 4 divided by 2 first.
Oh.
See how this is the division? Division is still higher, right, than the subtraction. We're not going to do the subtraction yet.
Oh.
Okay? So what's that going to become?
Is we make that into a negative 4, right? Or
Good.
is
So yes, yeah, you could say I could make this plus negative 4, and then we could do this, right? Or I can just leave the minus here, and I can make, I can pretend this is just regular 4 divided by 2. Either way works.
It's 2.
Good. It's 2, right? So now we have 95 minus 2. Okay. So then what's the final answer?
Yeah. 93.
Nice, dude.
Good job.
Good job, dude.
Man, I miss PEMDAS.
Yeah, PEMDAS, dude. Does that make more sense? Make more sense, Brinksy?
Yeah.
Okay, awesome, dude. I'm glad. Did you pay attention this time?
What was the thing for PEMDAS again? It was like, please excuse my dear aunt.
Yeah, what is it?
Sally."
Please excuse my dear Aunt Sally. I'm like, well, what did
No,
Aunt
Sally.
Sally do? Like, what? Please excuse her. What the
She
fuck
was
did
a
Aunt
dumbass.
Sally
Sally's
do?
the best, bruh.
Aunt Sally,
Sally
look
can
at
make some good cookies.
Sally looked kind of sus, with those cookies, dude.
Sally put some
Yeah.
weed in that cookie. What
Soft,
you talking
some
about?
soft oatmeal cookies or some regular.
Oh, dude, you like oatmeal cookies, dude? Ew, gross. What?
Yeah.
You put
I like chocolate
you put
chip
healthy
cookies.
shit in your cookies? No.
Yeah,
I'm just
you
kidding,
can eat
dude.
healthy, but just
Come
not
on.
eat
I like-
cookies.
I like peanut butter cookies are my favorite, actually. I love
Yeah,
peanut
our
butter
school
cookies.
got the most softest cookies ever. It's just for $1, one for two for two.
Yeah.
What? That's crazy. They be serving
Damn,
chips in my school for $1, and them chips are fake as hell.
Yeah, they be giving us like cup of lemonade and stuff.
Oh,
do
yeah.
that.
I remember we had like Subway at our school, and they sold us like the Subway cookies. But yeah, it was like 2 for $1 or
My
something.
school has a shop right
Yeah,
in
our
there.
school's,
Your school has
Fort
a
Dorchester,
shop,
so we
right?
can-
What? You have like a grocery store, like in your
I'll take a screenshot of
dude?
it.
Yeah, I want to see
if
that,
you
dude. What
Yeah,
the
our
hell,
school
dude?
is like is celebrating the is like supporting the Patriots.
Oh man.
My old school
Were you
used to
from
have
England?
a
Yeah, we're Fort Dorchester here.
Oh yeah, I retired from Warzone now. I don't play that no more.
Man, what's on your part? I was really about to go back, bruh.
I'm a big boy now. I stream Minecraft every day.
All right, that's the end of office hours here. I'll close it out for you guys. Thank you so much, guys, for showing up. I hope you guys learned some stuff. We're gonna be here 4 days of the week, Monday through Thursday. If you want to figure out when our next time is, check the Discord. Apologize for being late on today's office hours. I'll try to give you guys more heads up when that happens. Oh, also, we have a new student teacher role that I saw some of you guys started applying for. I can discuss that more during next office hours. Nolan, it's okay, dude. I'm super late, Nolan. Honestly, like Nolan, I was like 2 hours late. But yeah, so what we're doing is we're trying to encourage you guys, because I have a couple of you students who've been like, I'd like, this is cool what you're doing, Dr. Gold. I'd like to teach students as well. And I encourage that. I love it. So if you think you're pretty good at a certain subject or whatnot, or you feel like you could explain it to other people, apply to be a student teacher. We'll go through and we'll select a couple of you guys to be student teachers, and that will come with cool perks and rewards and, stuff for staying active.
Yeah.
Yeah, so that'd be cool. Does anyone have any last minute question? Yeah, what's up, Brinksy?
Can I send you my good grades and my steps for today?
Correct. Yes, you can.
Yeah,
you can
do that in good grades and steps.
You can do it in the channel. If you don't want other people to see, you can DM it to me. That's okay. That's all right.
All right, I'll send it right now.
Okay. Yeah, Nolan, dude. If you want to teach algebra, yes, sign up, dude. If I'm all for giving you guys teaching experience. It's something to like. I encourage you guys to help each other out. Especially because
can I teach the ABCs?
Wow.
That's like the easiest thing. in the
Because what's
world,
gonna
so
happen
can I
is
teach
I'm
that?
gonna put on the Discord a list of, like, for instance, like, if you're looking for someone that can help you with algebra, select these people. If you're looking for someone, we have this at
I
college.
want to teach on math.
Pardon?
I want to teach people with math.
Okay, cool. Well, you can put in there, be like, I'd like to teach people math in these levels and whatnot.
Wait, isn't it like a Google form?
Yes, yeah. There's a Google form that I set up that you can apply to teach for, and I'll go through the details of it. I'm just collecting the information right now. I'll see who all's interested, like what levels you guys think you want to help at, and then we'll structure the program and rewards according to that. But yeah, I love it.
I sent you my grades.
Okay, awesome. I will take a look at that. I need to add up all the bond coins all you guys bought with today's stream, which is great.
I also got MT points too.
And you got MT coins. Yeah, I'll talk to you, Mechanical. I need to set up the next. We may actually bleed the October challenge into November, just because I'm so slammed with stuff right now. Getting up to Halloween. What we'll do is we'll just extend it so that people can still compete during November. I have like a Halloween festival I'm throwing this weekend, and so you should see my living room. It's just filled with like speakers and like equipment.
Cool. Oh yeah. This is not like a question or anything.
Yeah.
I just want to say something.
What's up?
If well, this is more towards Brinksy. Brinksy, do you play or watch Minecraft in any way, shape, or form?
Not anymore. I used to.
Damn. Okay.
Yeah, my old friend Caleb used to play Minecraft, and he used to just stream it on YouTube and stuff. But I don't watch his streams anymore. He's all about Roblox.
I was gonna advertise myself a bit, but
yeah. Mechanical is he's doing streams now during the week where he plays Minecraft and stuff. So if you guys want to hop in and see what he's doing, interact with him, I
also found out this mod thing that I can do on Twitch where if you got like this is like once I'm able to set up donations and stuff, right? So like if you donate a certain amount or something, it sets a command in the game. Like if let's say someone gives like 1 bit, it spawns like a creeper or something like that.
Oh, that's cool.
So,
yeah.
so
Once you get to like
I'm waiting to get the affiliate and stuff.
Yeah, you need to get the affiliate. Once you get the affiliate, it'll do that.
Wait, you stream on Twitch, right?
Sorry?
Yep, I stream on Twitch almost every single day.
Yeah, and I encourage you guys to stream as well. I mean, this is how I started creating the following and whatnot, is just by streaming. So if you guys ever need help with streaming and whatnot, I'm more than happy to help you guys out.
Can you send me your Twitch?
You'll see it on Computer Lab if you scroll up.
Yeah, I made Brinksy. Oh, did I not make him a Minecrafter yet? Okay, Brinksy's a Minecrafter now. Okay, there you go. So he'll get the tags when you do it. Cool.
Yeah.
All right, I'll see you guys tomorrow. Have a great time. Awesome rest of your day, guys. Peace.